Hello guys, how are you? So can you all confirm in the chat that I am visible and audible? Hello. Okay, okay. That's great. That's great. So this is Shanwas here from Let's Upgrade team. So I will be here just for guide you how to mark your attendance and get all the docs, okay, related to the notes and everything. Okay, and after that, once I'm deal with that, I will onboard the trainer and you can continue with the sessions. Okay, so let me share my screen. I hope my screen is visible to all. Is my screen visible to all? Yeah, okay, that's great. That's great. Okay, so for the starters, here you can see the registration link. Okay, this is a link where you can register yourself if you haven't registered on the portal. Just click on it, it will take you to our portal. Let's upgrade portal. Okay, put your number, continue. It will send the OTP to you and you can just type that OTP. And if you haven't enrolled it into the particular bootcamp, you can enroll it from here. Once you enroll it, just wait for a few minutes. You can see you get an option of mark your attendance. Okay, so it is a free bootcamp to all. Okay, you will be getting your certificates after 3 days of the bootcamp completion. Okay, so but the necessary is you mark your attendance each day. Like for day one you have to mark your attendance, give ratings as you want. Okay, and here you can see your progress bar. Like once you mark your attendance, you can see your progress bar that you have attended this particular boot camp, and 33% of program has been completed. Okay, similarly or for day 2 and day 3, once the day 3 is completed, the certificate generation option will be available here. You can click on it. You have to give a little test, okay, as a proof that you have uh, attended the session for all 3 days, and you can generate your certificate from it from there. Okay, and one more thing is there that here you can see our student ambassador program. If you want to join our student ambassador program, you can join from there. The benefits are way much bigger than what you get from here. Okay, it is you get a swags, you get badges, you get multiple different rewards from here. Okay, as well as you get some exclusive workshops from our side. So it is beneficial to join our student ambassador program. And as our July student ambassador program has been started, so now you can apply for August one. Okay, it is a 1 month program, so you will get much more benefit from this. I hope everything is clear till now. So today's session will be taken by Gaurav sir. I think you might be knowing him very well because he has taken earlier also multiple sessions and all. So, okay. The one thing that is remaining is here, that for notes you can come over here, you can see all in one documentation, click on it, it will take you to the page where you can see all the things that you need. Okay, for example, you can see enrollment link over here. Also you can see all the links for each day and all the things. Okay, below that you can see notes, click on it, you can see agenda or a curriculum for this particular program. Okay, also as the session goes, as the bootcamp goes, and trainer provide us with the notes or something, we will be adding it over here only, so you don't have to worry about going anywhere else. You can just save this link with you and you can use this particular link for all the things. Okay, I think I am clear to you. If everything is clear, then we can start. I can bring the trainer on board and we can start with the session. Okay, I don't see any doubts. I will paste the link for documentation and attendance in the chats also, so you don't have to worry about it. You can copy and or open the link from there also. Okay, so I'm stopping my screen share and bringing the sir. Okay, hello sir, good evening.
Yeah. Hi, Shanawaz. Good evening. Sorry, I was on mute.
And yeah, it's okay sir. So yeah, I'm handing over you the session. You can take care of it. Okay.
Sure, sure. All right. Finally, we are live with some delays, and good things take time, people. So that's the reason that we had to cook up to be here till this point. And yes, Ravi Kumar wants an introduction. He will get it. So first of all, I am quite active in the chats. I like to be like that. I like to keep live sessions live, right? That's the reason of it. I do not want it to feel like I am into a recorded environment and artificial environment where I'm just not even looking at the chats, just speaking some things to myself and finishing the record, right? So that's not the point. The point of being live is to be able to interact, to uh, work around with doubts which can come up in person to person communication, right? So before we begin, my name is Gaurav Deep, and I myself am an AI enthusiast. I have been developing machine learning related solutions from almost 4 to 5 years now. I finished my post graduation in machine learning and AI from Amity University, which was a post graduation diploma degree. Now, in that 1 year full time course, we mastered things related to the what now we call the traditional machine learning, which is supervised, unsupervised, and a fair introduction to deep learning. When I when I started my career, the recurrent neural networks were the leading edge technology. The leading edge were over there, and from there we embraced transformers, and things changed. It's been almost 6 years to 2019 now. Along with COVID, the wave of transformers have changed everything for us in many different ways. And we are here today to discuss the agenda of how we can fine tune one LLM, such as any open source LLM for us, right? The agenda could be to use Gamma, or but it could be any model to begin with. Okay, so that's a little bit about it. So I have been working primarily in the audio, which is speech to text and text to speech, along with NLP based solutions. So we started off with classic spacey model. We trained NER models, we trained dependency parsing models, we looked into the relationship between the words with respect to their pronunciation, with their dependency with respect to the subject and predicate, and uh, what type of purpose they're solving in the entire text. So From there, we are here to the world of large language models, right? Can you please explain about today's title? Yes, definitely. So the agenda of today's title is to first embrace large language models, what they are. Okay, we will be starting off with transformers for today. That's the idea. That how do they work? Okay, what is the principle behind training it, and why it is a big deal? Why working with transformers is such a huge deal that we have to come up to points where we are finding different fine tuning strategies, such as low rank adaptations and quantized low rank adaptations and such things, right? So like, why training a large language model is a big deal. That's what we will be understanding today. We'll be understanding little nuances of the large language model, like what is query, key, value, and what are encoders, decoders, and how they're supposed to work. So that's the idea. That's day one. When we talk about day two will be more into the understanding of many different algorithms of parameter efficient fine tunings, such as we will talk about low rank adaptation or LoRa. Okay, so with LoRa we will also discuss how we can apply it. We will look at the quantized version of LoRa, and then we will discuss how we can apply it. We'll talk about the hyperparameters involved in those algorithms and how do they work. Day three would literally be going ahead and building our own specialized LLM, which can work based on our training data. We will be actually training something, and we will try to keep sessions theory plus coding involved. So whenever we will be discussing few things, whenever it is a good time to help you visualize things from code, I'll try to definitely bring that up, and we'll keep it that way, right? So that's the idea of how 3 days are going to be spent. Okay, so with that being said, all right. My last question today is: session is useful to first year CSC student? Well, yes. If you are into AI already, irrespective of what your age is, if you understand Python programming to begin with, if you understand what deep learning is all about, what are input layers, hidden layers, output layers, and how machine learning model is trained. Okay, what is training, evaluation, and testing? What these things are all about. Okay, what is machine learning to begin with? If you are familiar with these concepts, then it is definitely useful. If you are into uh, the large language models already, it is very much in your preference, okay, that you would like to learn. So yes, is it more machine learning oriented? Yes, of course. The idea of having deep learning has always been that it is in the umbrella of machine learning. So the session is purely about how we can fine tune a large language model. So the agenda of entire 3 days is about that, right? So with that being said, let us quickly start off, okay, with few of the basic explanations that we will be taking into, right? So, the very first thing is we will try to recap how AI has revolutionized the concept from attention to adaptation. We will go there, we'll talk about it. Okay, so let's start with it. So the very first thing is what is the content of this presentation is to inform you about the pre-transformer era and why transformers are important, and then how does attention mechanism come into picture, and then what are large language models, theoretically at least, what are they supposed to be, right? So with that being said, that's the idea. And Shri Lakshmi Rami is asking what is fine tuning. Well, we will definitely discuss that when the time comes. Okay, so you can definitely uh, buckle up. The flight or this journey is going to be interesting. Through this process, we will land on different topics, which could be fine tuning, which could be what is efficient fine tuning, right? So that's the idea. Uh, a request to please take classes according to beginner friendly. Yes. Irrespective of the request, we keep the sessions balanced. So do not worry. Things are going to be presented in a way that they are subtle. Each concept is introduced in a way that it doesn't hit differently. It goes with the flow. Okay, even for beginners. Okay, all right. So let us talk about the pre-transformer era, the era from where I started my at least my degree when I was into full-time post-graduation in AI. This is that era, and as soon as I landed with jobs post-COVID, uh, was the era where transformers existed, right? So the way first thing is limitations of early models, what they're supposed to be, okay, and what exactly is machine learning. So machine learning is the concept where you do not explicitly write code for everything. So for an example, if I have to create a calculator, and if I have to define rules like what is addition, what is subtraction, what is multiplication and division, that is, I'm writing a program with all rules. Okay, it's completely based out of an algorithm that I've designed. What if I do not have to teach machine the rules of how addition works or the rule of how multiplication work, but just give it inputs and outputs with the symbols? Okay, like I'll let machine have 2 and 2 with a plus symbol, and then give it an output as 4. So maybe it can try to understand what actually that plus symbol does. So no more I am writing a coding logic to explain it what is addition, but I'm making it learn. Okay, so, but these models were good. They were really efficient. They were really small enough to fit on even an i5 laptop. Like that's where I started my journey with, and they were really pretty cool to work on with. Like there were many different algorithms. I'll not uh, dive into it, such as what is supervised or unsupervised learning. But then again, the idea was that these even the deep learning basic models such as convolutional neural network or recurrent neural networks or LSTMs, again, they came up with the limitations of vanishing and excluding gradient. Okay, so any beginner or any enthusiast who might have heard about what is gradient descent algorithm, or what exactly are gradients, or uh, how does a machine learn, would relate to this problem. But again, I'll tell you what is happening here is that in machine learning process we are using a lot of derivatives. Okay, so when you derivate something, like for an example, uh, if you derivate something like x square, so derivative of x square is 2x. Okay, so again, if you further derivate 2x, the derivative of 2x is 2. Okay, and then if further derivate 2, the derivative of 2 being a constant is 0. So if you realize, the more you derivate, the more granular your value is becoming. You're breaking down, like obviously x square ka value, if you put 4 in the value of x, so 4 square is 16, and agar aap usko 2x se compare kare, if you compare it with 2x, so 2 into 4 is 8. Okay, so you have literally broken down from 16 to 8. And if you are using from 2x just 2, then from 8 you are going to 2, and from 2 you are going to 0, right? So the thought here is that you are depleting a lot when you are derivating into a lot of layers. So opposite of that is exploding. So which is where if we add a lot of layers into the deep learning model, we end up with derivatives leading us to a vanishing problem. That's what the problems were. Second problem was that long range was an issue. Okay, so even if I had to train a translation model, okay, suppose if I had to translate from English to French, for an example, so I had to create a vast data set of input columns showing us what is the sentence in English, and the output columns showing us exactly the mapped sentence in French language. Okay, and the idea was I would first start looking into the lengthiest sentence in my training data set. Okay, the lengthiest sentence in my training data set would be my input size of array. Okay, suppose if 100 words were there in the lengthy sentence, then I will pad every of the sentence to be of 100 words each. So if a sentence is of just 50 words, I would add 50 zeros to make it 100 length. Okay, so this is how I would map everything in the literal sense, and I would consume everything in a sequence. Okay, one after the other. So if you understand the concept of sequence and parallelization, parallel computing was really missing in this era. Okay, uh, and as we know, modern GPUs, graphic cards, such as commercial, non-commercial, both, especially talking about commercial products like A series or H series of NVIDIA, they are pretty much powerful. If you look at the the new architectures, Blackwell architectures, okay, and so on. So the idea here is that transformers completely broke this chain. They fixed these limitations because the data on the other hand was also increasing. Now the traditional machine learning algorithm was really good, but it needed less data, and talking about more data, deep learning came into picture, and with deep learning came these problems which found a quick fix from transformers. Now for all the people who are enthusiasts and who are thinking that we have solved the problem, it is never about solving the problem. So even if you try to give it a thought, इसको ऐसे सोच के देखो that internal combustion engines, IC engines, were developed many years ago. Like if you understand when was the first steam engine invented, you will understand that it has been more than 120 years that we are into the era of engines, right? Still today, research is going on how we can further optimize it, how we can improve efficiency, how we can bring more juice from same engine, right? So the idea here is that we never actually solve a problem, we only, solve a solution completely, we fix problems in it. So transformers definitely solve some of the problems mentioned in this slide, but they come up with their own limitations also, and which is why uh, there is always a pinch of salt that we have to take, that despite solving them, they on the other hand bring a lot of computational resource. Like you have a lot of head to put into to fit a transformer. Now with that being said, this is really a problem, that how we shift from this era, right? But then again, if you look at traditional algorithms, which is like a recurrent neural network, they had issue. Like for example, if I have to take up a sentence like hi, hello, how are you, so RNN works on state logics, right? So suppose hi is the first state, okay, and it will tokenize it, then it will take how, okay, so how will have a previous state which was hi, and it will then try to map a relation with this, but it will go one at a time. After hi will come how, and after how will come r, and after r will come you, how are you. So this is how the sequence will work, right? So that's really the limitation that transformer can definitely solve, is being parallel, okay. And then again, if you talk about RNN being an network of sequence and state architecture, right? So RNN had states it can unfold, like memory step one, previous memory step, previous to previous memory step. So based on it still had a context limitation, that the further you go deep, because I explained you how derivatives keep on decreasing. So the further we go deep, the value diminishes at some point, and there's a limitation to how much long-term dependency we can make. So it was really challenging to work with NLP despite having models like RNN and uh, LSTMs. Okay, so that's a little bit about how sequential models brought us limitations which are now being cracked by transformers. So why we call it a paradigm shift is because they definitely solve a huge hurdle in deep learning aspect, and the way they solve it is because is so huge that the popularity has increased to a level that we are comparing whether transformers can lead us to AGIs, okay, which is artificial generalized intelligence. So in the field of AI, there are concepts broadly classified at three levels. One is your narrow intelligence, the other is general intelligence, and the other is super intelligence. So we have a roadmap for ourselves. All the people who are into the AI research and AI development, uh, we classify AI into three groups. Okay, the very first group is where your traditional and deep learning algorithms would fit into picture, the traditional ones, which means narrow intelligence. What is narrow intelligence? Narrow intelligence is when a machine is good at a single task, but nowhere near to what a human can be. So for an example, if I've trained a machine learning algorithm to classify different breeds of birds, maybe the machine can do it a little better than a human, okay. Even if I give picture to a human and a machine, maybe human will have 99% accuracy, but machine can go for 99.5 or 99.8% accuracy, okay, beating humans by some edge. So that's one area. But give it tomorrow a photo of a leopard or a deer, it miserably fails because the machine was never learned to understand what a leopard is supposed to be, or what are the features of a leopard, right? But a human being smart enough, even if I give you a picture of a new bird which I've never seen, just by using my natural intelligence, I can still classify, hey, that this still looks like a bird to me. Okay, so that's narrow intelligence. Now, just by this example, you would have fair enough understanding what is general intelligence supposed to be. General intelligence is something that will be comparable to human level. Okay, so if I bring robots and students into a classroom and I graduate them all, I should have no difficulty in training both of them. Okay, a robot should also be something which is like a human is general intelligence. Okay, if I have to teach a human something, the kind of efforts I will take should be equivalent to, at least equivalent, if not uh, less, at least equivalent to train a machine also. And it should be able to perform and deliver like a human also, which is where the room for super intelligence is left. So when a machine would become superior to humans, okay, because humans are really bad at mathematics by the way how brain works. Some might be good at that, but even the best of us are limited because human brain is a little challenging when it comes to numbers. Okay, even if I give you a 12, 15 digit number right now, you can't memorize it in one go. So which is why machines are good at it, and the mathematics and algorithms work on numbers, which is why we have the concept of super intelligence, which will supersede humans in many aspects. Okay, so that's the idea. Now, Saiganesh is asking, can I train my AI agent with this Gemma or LoRa, in which where I'm creating an agent for employee attendance tracking system? Uh, well, first of all, to in order to train and in order to create your employee attendance tracking system, which is more like an HRMS, which will be your HRMS tool, which could be softwares like Darwinbox, or it could be softwares like Keka, or it could be any other software that you might be tracking, or maybe it's your own in-house solution for tracking employees. It definitely needs an LLM which is trained, fine-tuned on your specific data set, right? So whatever is that you're expecting from an ML to do, for an LLM to do, if you can definitely inspire from this 3 day session that how you can fine tune, but then you will have to adapt it to your data. Not, you cannot directly use this gamma model or whatever model we will use, but you can use the learning of how you can develop your own fine tuned model from here, right? So that's the idea about it. Cool. Now, with that being said, definitely, despite being beefier models, these models definitely bring in efficiency gains. Okay, the complete game changes now. So, for an example, if I have to say hi, hello, how are you to RNN, RNN is such a sequential machine that it will take hi, then how, then R, and then you, and then maybe a question mark in sequence, and then bring up an answer. Whereas LLMs, they can take everything all together. Hi, hello, how are you? In parallel, okay? In parallel boxes, they will take it. Parallel boxes, they will compute it. Definitely, this increases the efficiency gains, and with the efficiency, of course, comes the performance. Okay, now I can have much more improved accuracy and speed. But why is the speed not available on the surface? It's because these models are pretty huge, pretty large. Okay, so for an example, if an RNN is maybe 100 rupees, then the large language models are like billions of dollars. Okay, so that huge enormous difference is what relies in the model's architecture, and that, which is why we can expect 5 seconds to 15 seconds to 30 seconds of delay to generate the answer for us. But the kind of data they can chomp on to just generate this is enormous and huge. Okay, so which is why in fact they are known as the huge or big models. Okay, now what does transformer actually consist of? Okay, so if at all people are beginner here, if at all people are from non-tech background, if at all people have still not figured out what is deep learning or what is transformers, this slide is definitely good for you, because it covers things at a very high level of the picture. Okay, so on the very left of this diagram, what you see is an input notebook, right, which is like your input text. So if I'm asking transformer, can you write a story a horror story on traveling in a night bus journey to some hill station. Okay, so suppose if I'm asking this query, so what happens is first transformers have something known as an encoder functions. What are encoder functions to begin with? So function is something that takes in a well-defined, non-ambiguous input and gives us a well-defined, non-ambiguous output. What does this mean? So for an example, a function needs to know clearly without any ambiguity what its inputs are. Okay, so if the input is going to be string, it has to be string, it cannot be boolean. Okay, and if the output is supposed to be boolean, then will always be boolean. Okay, function will never surprise you throwing a integer or a double or a string. Okay, it is completely rule based. So that's a function. So what is an encoder function? Encoder function is something that takes the raw input. So if I'm typing something which is a string that, hey, can you write a horror story on a night journey to a hill station in a bus, this is my input, this is my literal input. And what encoder function will do is it will take this. Okay, it will extract the abstract from this. It will capture contextual relationships, dependencies of each word, or maybe in each token to begin with. Okay, so for now we can understand in machine learning at a high level each word is like a token to machine. Okay, or we will define what a token is, but each token is like a word. So can you write a horror story on a night journey in bus, okay, which are 11 words, to hilly station? Maybe like these are 15 different tokens, 15 different words, and using these words, transformers take everything in parallel. Okay, so when we take everything in parallel, all these words are in stack one after the very adjacent to each other in parallel. They are going into the function, and the function is now trying to find dependencies between them. Okay, can you, so it will try to understand, okay, you represents me, which is the large language model, and the task is to write what, okay, and how. So what, how, these questions, these dependencies will be learned with each other, and a contextual map will be generated, that what is the sentence, what are the words, how are they related, what it is trying to pitch, what is the idea, what is the thought, what is the action, what is the subject, what is the predicate, everything will be mapped here. And inside this space we will get a matrix which will hold it. Okay, yes. So with this matrix, now we will have enriched matrix which has something which explains what the user wanted. Okay, so just stopping here at encoder, looking at the chats. Okay, is this live? I was able to rewind, so not sure. You can always rewind live sessions. Okay, you cannot just forward it. Make sure if you can forward it to like from the live space, you will not be able to do it, right? But rewind is always available. So does fine tuning include parameters like temperature and case space? Well, not exactly. Not exactly. These are more about the model control parameters. Okay, but we will talk about what fine tuning includes. Okay, but it does not for now. Okay, all right. So transformers are a part of LLMs, right? Well, let us say LLMs are a part of transformers. Transformers were the concept. Transformers were the original structure generated, and LLMs are built by using transformers. So transformers are the genetics or the backbone of LLMs. Okay, so transformers are part of LLMs. Yes, that is right. So Mikey, it's completely right that yes, transformers are part of LLMs, which means that LLMs are built using transformers. So now we have understood the part of how encoder is supposed to take a free text, convert it into a matrix, or let us call it a vector now. Okay, so a good time to take notes, students, that people who are finding gaps in this learning understand what vectors are in mathematics and how they can be used to represent two-dimensional or three-dimensional space. That is something that you have to understand. Understand what derivatives are, understand what is backpropagation, and how does a deep learning network train what is hidden input and output layer. Okay, and then what is what are gradients, what are weights, okay, how do they update, what is bias. Okay, so these few things, now they are recorded, you can rewind it, note it down, and learn them if you are not yet aware of it. Okay, so with this being said, now let us go to decoder. So decoder is something which is like someone who knows how to abstract information or how to generate output by using encoder ka information. Okay, so imagine that human language is something that encoder understands. Encoder is like a translator. Okay, it understands human languages, and it writes a language which decoder understands. Okay, now decoder will take that, and using that it will generate something which we can understand back. Okay, so that's how the encoder and decoder work. And they dynamically use this relationships. Okay, and there's always a layering structure. Like for an example, encoder itself would have 6 layers or 6 different hidden layers. Okay, so in it, so in deep learning the concept is that each layer consists of neurons, and neurons are inspired by how our brain works. Okay, because AI is inspired by the best intelligence on this planet, which is humans. So humans can work with neurons because that's there in our brain. We call it biological neuron. And similarly, we can create something which is a concept used to create artificial neuron is weights and bias. We can use them to create a neuron for us, and we can have hidden layers which try to understand how our brain mimics. Similarly is how artificial neural network works. Dendrites, axioms, neurons, जो भी कुछ हमारे दिमाग में लगा है, complete neural structure, exactly we try to mimic it. Whatever we know about human brain, we are trying to mimic it using deep learning. So deep learning is all about mimicking the concept of the neurons in the brain. उसी तरीके से hidden layers, output layer, input layer होते हैं. But input is something that takes input, output is something that gives output. Hidden is where this magic of deep learning is all about, that how our brain is supposed to work. Similarly, these hidden layers are supposed to work. So there are a lot of layers. Encoder में काफी layer है, decoder में काफी layer है. Then there are attention mechanisms. I'll talk about it, but I'll try to keep it informative, rich, and still high level. Okay, that's the idea. So on the left, what you see is the actual diagram, or in fact, that's still not the actual diagram. It's maybe or काफी layering है, stacking है, but representation is something like this. Okay, so but for the people who want to learn it in a little simpler manner, वो right वाले diagram पे ध्यान दें. So in the right diagram is little more higher level of this interpretation. Okay, which is input pre-processing, encoder, decoder, and output pre-processing and output post-processing. Okay, so that is the idea about how it works. So basically what is happening is that, suppose if I'm giving an input that, hi, can you write a horror story on traveling in bus at night to a hilly station? So all this text is pre-processed first. So remember I told you words are like tokens. So, well, the concept is like what the transformer will do is it will try to break all our string. Like उसमें white space भी आ गए, full stop आ गए, question mark आ गए, any special character आ गए, any part of the string it will try to break into a fixed size of container. और हर container में we will try to store these characters. Okay, so I'll quickly try to visualize you token counter OpenAI. Okay, so for an example, if we go here, okay, prompt token, write a horror story about traveling in a night bus to a hilly station. Okay, let me copy it, take it to a little different website which is a little better at token visualization. Okay, let us go here, let us paste it, and yes, right on this website, if you see, I'll try to zoom it. Okay, so do you see WRITE, right, is one complete token in itself, and then that green blocks, white space and A, it is a one complete token in itself, and then white space and horror is another token. So all these colors are different tokens. Okay, if you see hilly, in fact, being a single word, it is divided into white space and H as a single token, and illy, which is ILY, as another token. So how tokens work is not the agenda, but there are different models which can help you tokenize it. Okay, so this is for GPT-4 3.5 Turbo. If you go to something like Llama 3, so the tokens will change, and this is how the tokens are supposed to be. And for Gemma, this is how the tokens are supposed to be. Okay, so it completely so the BOS is like the start of the script which comes for Gemma. Okay, so again, how large language models will tokenize, well, that is a different story, but the idea is that tokens are nothing but hum string ko we are breaking it down, and just a second, I'll just go back to slideshow. Okay, yes. So tokens are nothing but a way in which natural free text will be broken into machine compatible language, and this is where positional encoding will come into picture. Positional encoding kya hai? We will in parallel. Remember, I'll repeat again. Transformers take each word in parallel. So complete sentence ko parallelly lenge, and we will place positions like where are these words in the entire sequence. See, problem kya hai? RNN was taking words sequentially. So RNN knew कि पहला वर्ड कौन सा था, अब कौन सा आया, इसके पहले कौन सा था, इसके बाद कौन सा, you know, it is coming, so it knows कि sequence क्या था, पहले पहले क्या था. अब जब हम if we are putting everything in parallel, we are losing sequence. So हिली अगर वर्ड है, बस अगर एक वर्ड है, हॉरर अगर एक वर्ड है, तो ये हॉरर इन द एंटायर सेंटेंस कहाँ लोकेटेड है? So that's what positional encoding will capture. वो उस वर्ड की पोजीशन भी कैप्चर करके रखेगा कि पूरे सेंटेंस में what is the position of that word, but parallelly सारे words ले लेगा. That's the idea of how the transformer will take into picture. Then the real magic is in the multi-head attention, जहाँ पर there are multiple layers of attention mechanism. Okay, and each of this layer has something phenomenal to bring into picture. What makes LLMs or ChatGPT or Gemini or this large language model is so interesting. And then of course there's an output layer like a feed forward layer, which everything is a part of encoder. और डिकोडर का भी पार्ट यही है. डिकोडर आपकी आउटपुट एम्बेडिंग्स लेगा, एनकोडर इनपुट लेगा, it will post process it for output, and then you will get the output from there. So this is at a very high level how the transformer is supposed to work. Remember, for a recap, people, what we have learned, transformers के अंदर input आता है, converts into embeddings, which are nothing but vectors with their positional and embedding layers. It works around through something known as encoder. Encoder क्या है? We just realized that encoder is nothing but something that converts a free text or an embedding text into a rich information matrix. ये matrix क्या है? It contains a lot of information, like all the relationships, all the meaning, all the abstract, all the information एक matrix में डाल देता है, and this matrix is now consumed by our decoder. Okay, so that's the idea. Some transformers are only encoder like BERT, some transformers are only decoder, and some transformers are a mix of both of them. So ChatGPT and everything, the OpenAI, Gemini, they are the complete GPT architectures which are based on these concepts. Okay, so attention mechanism पे थोड़ा सा we will focus over there how it is working. Okay, so first of all, self attention allows the model to emphasize on words in a sentence, enabling it to understand the contextual relationships. Okay, so so मान लो there's a sentence like the bank of a river. So here अगर मैं parallelly सारे words if I'm putting into the model, the bank could literally mean जब हम car race कर रहे हैं, there is an angle of bank, तो वो वाला angle of bank है, या is it the bank in which we do currency money, is that the bank, or is it like the landform near the river? So ये relationship is where what attention layer brings into picture. So self attention will let the model be aware of relation of this word with respect to everything, and किस word पे कितनी attention देनी है, which word is more important for us to produce the output. Like for an example, for our case, in our case where we were doing the token counting. Okay, so if we go to token counter once again, and if we look at our word, definitely okay, token counter, definitely just by looking at this thing, I think most important is horror story. Okay, traveling, night bus and hilly station. अगर मुझे ये as hashtags भी आप दे दो ना, even just as hashtags, horror story, night journey, bus, hill station, even these 4 words out of this 15 words ka sentence, I can understand what you're trying to say. So that is what attention mechanism will do. It will try to bring into attention what words are, how they're related, or how they are important to us. Okay, then again, जैसे again वो positional encoding का भी concept, I'll just clear it out to you. For an example, suppose words and dog bites man, ये sentence है, but then I just told you कि ट्रांसफॉर्मर सीक्वेंस में वर्क ही नहीं करते, दे टेक एवरीथिंग पैरेलली. सो डॉग अलग जगह जा रहा है, बाइट्स अलग जगह जा रहा है, मैन अलग जगह जा रहा है. But by using this sentence, by using these words, I completely lose the sequence. Was it man biting dog or dog biting man? How is this sentence? तो वो positional encoding हमें देगी. It will retain के भाई dog man को काट रहा था, man dog को नहीं काट रहा था. So that relationship will come into picture. And then again, since it is parallelly ले रहा है, आज 3 words हैं, tomorrow there will be 30, then there will be 300, and there is you can say a limitation to how much parallelly it can process, like, but it is a pretty huge number. Like if you look at Gemini, for an example, if we go to a Gemini flagship model, if I just go for Gemini Google over here, if I try to open it, okay, I think यहाँ पर tokens do not come up like that way, but let me go to AI Studio, Google, and here you will realize that unit 10, 100, 1000, 10,000, lakh, 10 lakh, 10 lakh tokens, not words, 10 lakh tokens ये मॉडल एक साथ पैरेलली प्रोसेस कर सकता है. When we go to 2.5 flash, again 1 lakh tokens, pretty huge number. 10 lakh तो like it's ब्रेन फ्रीजर के इतना सारा टेक्स्ट आप पढ़ भी नहीं पाओगे जितना ये मॉडल एक साथ पैरेलली प्रोसेस कर लेता है. So again, depending on different models, the capacity to take parallel computation is there, but even 1 lakh parallel words is pretty huge for me, and mostly all of my problems will be solved by such a model, right? So this is the idea. See, self-attention kya karta hai? It is contextually understanding the sentence. For an example, I give you certain examples that you can refer to here, okay? So self-attention, first of all, query की value logic पे work करता है. I'll give you this explanation beautifully. Just give me 2-3 minutes. I'll give you this explanation, and then it passes through a softmax layer. ये भी समझा दूंगा बहुत अच्छे से what is softmax layers. Then comes the attention score, and finally attention फिर realize करता है that what is my output supposed to be. So let us take an example over here, okay? So suppose if we are 100 live people over here, and I have a sentence, okay? I have a sentence. Let me switch to better visualization over here, okay? I'll start with a blank canvas. I'll try to explain you this query key value quickly. So for an example, we are live audience over here, okay? I'm just trying to draw some symbols, okay? Okay, wait, let me try to zoom my screen a little bit. This is little, I think this should work, okay? Yes. So these are like parallel users, okay? So for an example, suppose I have a 100-word essay, okay? I have 100-word essay. So what I will do is I have basically 100 students also, okay? So I will assign each student a word, okay? I will assign each student a word, which is like their responsibility, unka task hai, okay? This is what they have to do. So I will have, say, student 1 over here, okay? Ye first student hai. It has maybe hamara wo write a horror story example le lete hain. This is student 2, write student 3. I'll not waste time drawing a lot of students. I'll just draw 4 5, okay? Horror. If you are following up, if there is any doubts, you can always come up, okay? Horror story, okay? Yes. So अभी तक का I think you are getting the example, right? ये आपका ट्रांसफॉर्मर्स कैसे वर्क करते हैं, इनपुट से लेके दे आर डूइंग प्री प्रोसेसिंग, एंड प्री प्रोसेसिंग होने के बाद आपके ये अटेंशन लेयर पे आए हैं, या आपके बेसिकली एनकोडर लेयर पे आए हैं, एनकोडर के अटेंशन लेयर पे आए हैं, विच इज वेयर ये पैरेलल कंप्यूटिंग हो रही है. दिस पैरेलल कंप्यूटिंग इज टेकिंग एवरीथिंग इनटू अकाउंट, ओके? एंड ईच ऑफ देम हैव देयर पोजिशनल एनकोडिंग एंड इनपुट एनकोडिंग, ये सब इनके पास है, okay? Now what is happening is each of the sentence mentioned here has क्वेरी, ठीक है। बेसिकली राइट क्या करेगा ना, राइट मैंने स्टूडेंट को दे दिया है। सो सपोज इफ आई गिव यू, सपोज इफ आई कॉल के हाय माइकी और हाय नीलेश और हाय हर्षा और हाय आकाश, राइट, आई जस्ट गिव यू दिस वर्ड, मैंने आपको बोल दिया राइट। सो देयर इज एन इमीडिएट क्वेश्चन आपके दिमाग में, क्या सर, व्हाट, ओके, व्हाट डू आई राइट, ओके, हाउ डू आई राइट, वेयर डू आई राइट, how much do I write? So these are queries that will come to you, and since you know there is no trainer available, you will try to ask this query to your fellow students, okay, कि यार मुझे वो write करके word दे दिया है, but what do I do with it? Do you have any idea about it? So all the students, okay, imagine all the students also have their query. इनको भी कहीं ना कहीं doubt तो है that what is this word supposed to do, but since they are also fellow members like you, they will try to give you some idea. Okay, actually I got a word horror, okay, so maybe you have to write something about horror. So write को ये बताएगा, maybe you have to write something about horror. Story will explain, maybe you have to write something about a story, okay. And then what will happen is, basically each of the character here will also have a key which will be their identifier, okay, and a value with respect to each other, okay. Value मतलब इनकी value हो गई है, and key will be like mapping, okay. Key एक तरीके से mapping है, how do these words map, okay. So key एक तरीके से mapping है, and all of them will have it. जैसे for example first student को query मिली थी ना right, तो इनके पास भी अपनी key है and इनके पास भी अपनी एक value है, okay, and ये सभी के साथ बनती है, like right will match with a horror story, and then A भी वही करेगा. A will also, just a second, let me go back to that one. I think yes, A भी right के पास जाएगा, A भी horror के पास जाएगा, A भी story के पास जाएगा. Similarly, even the story will go to horror, story will go to A, and story will go to right, and ये permutation combination will happen with everyone, okay. And from there, what will happen is they will try to understand relationships with each other, and this is where the self attention mechanism will come into picture, okay. So imagine you're in classroom, students and they're actively seeking okay, what is the assignment all about, then they will come back with each other. So for an example, student 2, student 3, student 4, student 1 के पास गए with their responses, okay, और वहां से स्टूडेंट 1 को थोड़ी क्लैरिटी मिली कि मुझे स्टूडेंट 3 और स्टूडेंट 4 के साथ थोड़े स्ट्रॉन्ग रिलेशन बना के रखने चाहिए, बिकॉज दे आर एबल टू एक्सप्लेन मी व्हाट माय रोल इज. सो query is like the student who is asking for help. So every word will query to every other word permutation combination में. Keys are nothing but इनके पास there are certain notes, जैसे 3 के पास horror है, 4 के पास story है, okay. So notes are nothing but they will signal to each other कि ये मेरे notes हैं. Values are how much are they valued to each other. तो ये एक दूसरे के साथ अपनी वैल्यूज बनाएंगे, ओके. सो सेल्फ अटेंशन क्या करेगा, ऑल टोकन्स आर साइमल्टेनियसली पैरेलली, रिमेंबर स्टूडेंट्स, दिस इज हैपनिंग पैरेलली, इन पैरेलल दे आर आस्किंग ईच अदर एंड डिजाइनिंग समथिंग नोन एज के हाउ इंपॉर्टेंट आर each word to me. So कल चल के अगर मैंने 1 lakh words का भी एक पैरेलल कंपटीशन भेज दी, तो when the first word will compute itself with the 1 lakh पोजीशन का वर्ड, जो 98,000 पे 99,000 पे पोजीशन में जो वर्ड होगा वो भी एक दूसरे को मैप करके अपनी रिलेशन और अपनी अटेंशन के थ्रू अपना इंपॉर्टेंस बनाएंगे कि 90,000 वर्ड के लिए फर्स्ट वर्ड कितना इंपॉर्टेंट है, ओके. सो ये मैपिंग जो है, दिस इज व्हाट अटेंशन डज. सो फॉर एन एग्जांपल, आज हम एक टॉपिक पे बात कर रहे हैं विच इज हाउ टू फाइन ट्यून अ लार्ज लैंग्वेज मॉडल, हाउ टू फाइन ट्यून अ गैमा. एंड स्टार्टिंग में हमने डिस्कस किया था व्हाट आर न्यूरॉन्स. ये आई थिंक 15-20 मिनट पहले वी वर टॉकिंग अबाउट न्यूरॉन्स, ओके. एंड नाउ व्हेन आई टॉक अबाउट न्यूरॉन्स, तो वो 15-20 मिनट पहले वाले वर्ड को जाके ये वाला वर्ड मैप करेगा, बिकॉज दिस इज द कैपेसिटी ऑफ लार्ज लैंग्वेज मॉडल टू मैप इवन to a word which is even 50,000 words पहले और 90,000 words पहले, और डिपेंडिंग on the context memory. So now is where you know कि ये words और ये sentences जो है whatever we speak naturally, they are literally around under the limit of what this transformers can capture parallelly, which is why we say कि ये अब context window की problem solve कर देते हैं, ये limitations of memory की problem solve कर देते हैं, because now long term memory dependency is solved. Now they can even the 90,000 word can have a relation with the first word which was spoken, which is really great. Because even our human brain will freeze हो जाएगा, cooked up हो जाएगा अगर उसको इतनी पुरानी मतलब मैं आपको बोल दूं ना 25 minutes पहले if there was something that I was explaining, remember it now, you will not be able to remember it because हमारी mapping इतनी strong नहीं है. But this is how transformers actually map. Okay, so I'll quickly try to visualize this to you through coding also. Coding se bhi you will be able to better understand it. But through code, I'll keep the example little short. Okay, I'll not take thousands of words. Okay, so let us. I hope my screen is shifting. Let me just check. Okay, so self attention example.ipynb. I'll create a notebook. I'll try to zoom in. Let me know, students, if the zoom is working for you. You're able to read now. Okay, I'll try to zoom things for you. Okay, I'll do Control V. I'll cross it. I'll generate. Okay, how attention mechanism works in transformer models. Okay, let's try to add some code. We will use input sentence, say for an example, say dog plays fetch. Okay, so for an example, this is what we will use. We will simply use numpy, but transformers will use their different format. Okay, TensorFlow, yeah, PyTorch, yeah, these models, they have their own tensors in which they store, not just numpy array. Okay, all right, but this is a good platform to numpy is very much similar to it. Okay, so each word देखो मेरे पास क्या है, I have dog plays fetch, so I have a token for a dog. Now since I'm giving an example, I'll take a random value है ना, so I'll take any random value, say 1,0. Maybe I'll give it some negative value, से कुछ भी हो सकता है ना. This is a vector. Okay, and this is an array. Okay, ये अपनी space represent करता है. Similarly, there could be token place. Similarly, there could be token fetch. Okay, so again, these are very random values. Trust me, like reality में whatever model we have trained, it will have its own embedding. Okay, so let us see how our embeddings look like. Okay, I'll print token dog, and then I'll print token place, and then I'll print token fetch, and I'll do Control Enter. I'll run this model, and you will see these are tokens. Okay, ये मेरे tokens बन गए हैं. So remember, if we jump back over here, if we jump back to token counter, okay, how these are different tokens. So if I'm saying dog plays fetch, तो ये dog purple में, plays green में, और fetch yellow में. This is it. Okay, right over here. Dog ये, plays ये, fetch ये. Okay, this is the input that my transformer has. Okay, but in reality it will have like dog. If dog was a part of training, उसका एक fixed encoding बनी होगी, place की बनी होगी, and this is also based on the positional encoding भी बनेगी, ये encoding भी बनेगी. But this is an example, ये बनेगा कैसे. Now again, weight क्या होता है? Weight is what the model has learned. Okay, everything that the model has learned is in the weights of the model. Okay, so we will have to design. Okay, so first of all, I'll add a markdown. Okay, defining sample tokens from input dog plays fetch. Okay, I'll run it. All right, now I'll add one more markdown over here. Defining some dummy weights. Okay, dummy weights. In reality, these will be trained weights. Okay. Okay. Now we will define some dummy weights. So similarly, in order to do that, what we'll have to do is we will have to basically define query key value. Remember I told you query key value are the weights. Okay, so we will just use numpy.random module to just visualize them, and let us visualizing the weights. Wait for is again comma wk, and then weights, and then weights, and so these are our weights. Okay, w with respect to q, w with k, and w with value. Okay, weights of these things. So we have randomized these weights. Okay, and we will compute now query key value vectors for each our token. We will focus. मान लो जैसे यहाँ पर 3 words हैं, dog plays fetch. Okay, so we'll focus on play query कर रहा है. So किसको query करेगा? Play will query to dog and fetch both, and then we'll try to understand के what are the relationships with you people. Okay, like what exactly are you people holding in. So let us add a markdown cell. Okay, delete. Now we will compute how, say, a word, let me call it token, play will query the other tokens in the sentence. Okay, so this is what we will try to do. अच्छा ये गलती से code बन गया है. Right click copy, add a markdown, paste, and this is what we will do. Okay, so what will happen is, let us try to visualize this. Okay, see, play is a querying token. So we will generate a dot product. Now remember, in reality what we are doing is, if you understand the matrices, तो आप एक matrix को दूसरी matrix का dot product बना रहे हो. Okay, so if there is a matrix 1 2 3 4 dot with 4 5 7 8, ऐसे आप इनका mix करके एक matrix बना रहे हो. So what will happen is token plays. So token plays कहाँ पर है? So we have a token plays over here, है ना? So ये token is like this 0.5103. इसको यू आर मल्टीप्लाइंग विद व्हाट? वेट ऑफ द क्वेरी, क्योंकि ये क्वेरी है अभी. ठीक है, तो ये क्वेरी का वेट है. सो वी आर मल्टीप्लाइंग इट विद क्वेरी. ओके, सिमिलरली डॉग की भी क्वेरी बनेगी, फेच की भी क्वेरी बनेगी. एंड व्हाट वी विल डू इज, नाउ वी विल फाइंड वैल्यू. ओके, वैल्यू of these two products, value of dog and value of fetch, for an example. Okay, so again you can try to print visualizing query key value for token play. Okay, and then query for play, key for dog, value for dog, key for fetch, and so on. We will just try to print it and realize query for play ये है, key for dog ये है, and this is how these things are coming into picture. Okay, so let us just roll back whatever we are doing over here. Okay, see, we are trying to understand how attention mechanism works. Let us go back to our introduction. So first of all, it uses query key values. Okay, and what it does is it uses a dot product on top of them. Okay, so if we check over here, okay, what it is doing is it is trying to encode everything. It's trying to find relationships. So multi-dimension में हो क्या रहा है? For example, bank in river के अंदर जैसे it is trying to find relationship between river and bank. Similarly over here, each of the queries trying to find relationship with each other using key values. Okay, so we have just using a random example, we have found out what key and values look like. Actually में ट्रांसफॉर्मर में क्या चल रहा होगा, but at the same time please appreciate यहाँ पर कितना सारा mathematics लग रहा है, like dot product of this, dot product of this, dot product of this, dot product of this, and this. Okay, so much of dot products are involved over here. Now inside this dot products, if I quickly escalate, okay, this is again a matrix just of 3 vectors. So it still sounds easy, but इमेजिन अगर ये मैट्रिक्स ऑफ 512 डिफरेंट पॉइंट्स हैं, ये एरे के अंदर 512 एलिमेंट्स हैं. ओके, एंड देन यू आर मल्टीप्लाइंग 512 इनटू 512, नॉट जस्ट वन टाइम. ये आप कितनी बार मल्टीप्लाई कर रहे हो डिपेंडिंग ऑन द नंबर ऑफ सेंटेंस वर्ड्स और नंबर ऑफ टोकन्स इन द सेंटेंस. ईच टोकन इज मल्टीप्लाइंग विद ईच अदर लाइक दिस. ओके, एंड आफ्टर दिस मल्टीप्लिकेशन व्हाट इज लेफ्ट? ओके, सो फॉर द पीपल who are guessing, I think the idea is very very straightforward. Okay, now we compute what? We compute the score. Now we compute these scores. Okay, so So dot product करोगे आप, so after dot product you will determine के how much they are relevant to each other, है ना? So for each of the word in the sentence. Okay, now let's try to do that. So for example, if I add a code over here, so हम similarity ढूंढेंगे. Again, similarity is nothing but dot product. Okay ना? So what we will do is we will just take up कैलकुलेटिंग सिमिलरिटी स्कोर्स. तो अगर प्ले और डॉग की के अंदर की मुझे प्ले के हिसाब से क्या करना है, मुझे डॉग के साथ भी और फेच के साथ भी देखना है वो कितना ज्यादा कंपैटिबल है. सो आई प्रिंट दो स्कोर्स. ओके, प्रिंट सिमिलरिटी ऑफ फेच. So what will happen is के ये तो नेगेटिव जा रहा है बट ये पॉजिटिव जा रहा है. What will happen is के प्ले अपने आप को ना फेच के साथ बहुत ज्यादा रिलेट करेगा. Again, these are random values, but reality में this is how they will find relationships. वो dog को इतना ध्यान नहीं देगा. Play what play will understand is के I am very much interlinked, or I have a very strong relationship with fetch. क्या खेल रहे हैं? Fetch खेल रहे हैं. कौन खेल रहा है is not important to me. But this is again, this is really black box. ये कैसे relationships बनते हैं? It depends on how you have trained the model and how the model's mathematics और model के weights, values कैसे design हो रहे हैं, उसके हिसाब से ये values आती हैं. हमने तो बहुत randomly, we took very random values. Okay, np.random module हमने use किया. But based on that, I gave an example that based on what we coded, this is our output. That this is the relationships that we have. Okay, now since we have relationships, we can now use the softmax function. Remember that once we have run through all the query key values, we use softmax function. Softmax function क्या करता है? It compresses all your values from high to low between 0 to 1. So why do we need it? So that we have a range. Okay, we have a normalized layer now. So softmax normalize करता है score को and all the probabilities, because concept of probability is that it can be minimum 0 and maximum 1. So if they are extremely related to each other, मान लो in any two words are extremely related to each others, they will have after softmax उनका output होगा 1. If they are polar opposites, they're not at all related to each other, unka output hoga maybe 0. So in reality, for an example, if there are words like king, okay, and ruler and male, so male and king and ruler and king will have very strong values like 0.8, 0.9 का इनके बीच softmax का output बनेगा. Whereas king और queen के बीच में maybe 0.6 का बने, because they are again linked to humans only, है ना. But a king and a dog के अंदर काफी less match बनेगा, maybe 0.1 being as both are biological things, right? So this is how this entire logic in coding will work. ये coding up, you will never be able to visualize it. ये आपको कहीं दिखेगा भी नहीं. In Python you will just do llm.predict, है ना. But at the back of it, try to imagine how much intense and vast computation is happening. Okay. So similarly, based on this, we will be able to simply do nothing but print हमारे attention scores. Okay. So for an example, if we compute similarity score, attention weights for dog and fetch represents this. Okay, ये इनका attention weights I है, and this is the complete idea of how attention works. Okay. So now that you people have a little bit of idea, मान लो कि even if you're able to just catch 10% of this, don't worry, you are in the same plate. If you just understood that attention mechanism kya kar raha, it is trying to find relationships between all the words, that is very much important, because the agenda of this 3 days bootcamp depends upon the idea to just appreciate kitna sara mathematics hai. Because I give you a random sample of just 3 vectors or 3 elements per array. In reality, there are 5 and 12 or thousands or hundreds of elements in an array, and there are so many of computations in just one layer. And this is just one attention layer. As a 6 attention layer and encoder ke andar. So 6 times each attention is a calculation kar raha hai, and through this calculation they are getting attention scores, which we just generated now, and then they are generating their final output. Okay, so why they're called large language models, I think now the idea is very clear, because they have a lot. I cannot emphasize on the word lot, the humongous, vast, abnormally huge nature of calculations involved here. They are nothing but language models, but large in a sense that they involve a lot of computation, lot of training, lot of billions of parameters. Okay, simple machine learning के अंदर एक simple input layer होगी, simple output layer होगी, और maybe hidden layer में 4 न्यूरॉन होंगे, 2 न्यूरॉन होंगे, 10 न्यूरॉन होंगे. But in large language models, it's not just unit tens, hundreds or thousands. It is billions and millions of parameters, millions and billions of parameters which are there. So many amount of neurons which take input, so much of mathematics. You can just imagine this is like a super science fiction. And in reality, in 2025, itna sara calculation hone ke baad you're getting an output, right? Which is why it is not at all easy and not at all convenient that anyone can host an LLM, right? To host an LLM, it requires a good amount of GPU. So even if you have to host a simple, like normal, like 70 billion ka llama model bhi host karna hai, and in a proper I'll not say proper, I'll say एक mediocre level पे, मतलब production level पे इसको host करना है, you need at least 10 to 12 lakh rupees का machine to host it. If you want to run it even at a casual level, उसको normally चलाना चाह रहे हो, you need at least 3-4 lakhs of machine to run, maybe at least 14090, 13090 to run even in the quantized way, I will say. But now we have small language model also जो कि 8 GB GPU 12 GB GPU के अंदर और even CPU level पे भी चला सकते हो, but at the cost of latency. But that's what language models are all about. So large language models क्या हैं? They are based on transformers. Okay, and how transformers work? They have encoder, decoders, and attention mechanism. Okay, so they are good at understanding the context. They are good at language generation, language translation करवानी हो. They are really good at it. So natural language, whatever tasks are there, English, Hindi, Marathi, Hebrew, Chinese, Mandarin, whatever you take it. Okay, all this language, they're good at it, they understand it. Real world ke andar they can do so much: healthcare, finance, education, manufacturing, automotive industries, automation projects, customer supports, chatbots. Sub ke andar there's enormous, and in fact there's infinite application of where large language models can be used. So finally, we come to how do we control these large language models. So large language models to control करने के लिए first thing is prompt engineering. Prompt is something that we give to the model that hi, I want you to write a story, and then we can write more details into that story. I'll give you one example. Okay, let's take one example. For an example, let us go to Google Gemini. Okay, and ये example को finally run कर ही देते हैं. Whatever we will just type it out. Okay, write a horror story about night journey in bus to a hill station. Okay, for an example, this is a very vague prompt. So prompts हम इसको कैसे design कर सकते हैं? See, it is giving me the answers like this. Okay, but literally मुझे इतना बड़ा story नहीं चाहिए था. So which is where prompt engineering comes into picture. Okay, I'll just redesign it, right click, copy. Okay, and this is the output. I'll paste it again. Okay, with the 4 paragraphs exact, and first paragraph explains Gaurav, who is a AI engineer and never believes in ghost, is traveling to Shimla and so on. Okay, with maximum 200 lines, or 200 is still huge enough. I'll say 50 lines. Okay, so this is what prompt engineering is all about. We can control the output of the model with prompts only. You see, now the story is much more to what I want. 1, 2, 3, 4 paragraphs only. It starts with the character that I want it to be, and the location where I want it to be, and I have controlled the output, how much sentence and paragraphs I want. Now you can compare it to the previous output, which was really bland, and you can just keep on reading it, and you can add your taste to it. So that's what prompt engineering does. So prompt engineering is one way that you can control LLM's output, but again, it has its own limitation. Okay, then decoding parameters are where, one of the students in the starting was asking that what is this the temperature, max tokens, p tokens, probability tokens are supposed to do. So decoding parameters are something that are available in developer modes or in studios. You can see I can restrict temperature. It ranges between 0 to 2, and for some LLMs between 0 to 1. 0 means to be more deterministic, okay, and temperature and p count are very much similar to each other. Deterministic का मतलब क्या है? That suppose at every point, see, transformers or large language models are probabilistic models. What does it mean? They never actually really in real sense, they never understand language. उनको हिंदी, इंग्लिश, मराठी, गुजराती कुछ नहीं आता है, उनको कुछ भी नहीं आता है. It's just tokens for them. All they know is कि ये token जब आएगा, what is the probability of the next token to fit here? Okay, a good ruler is कि आगे क्या लगाना है, also is, am या कुछ और. तो वो based on the relationships attention mechanism जो बना रहा है कि नेक्स्ट वर्ड कौन सा होना चाहिए. तो देयर कुड बी प्रोबेबिलिटी, मे बी एलएलएम के पास 10 20 30 ऐसे डिफरेंट वर्ड्स होंगे जिनकी प्रोबेबिलिटीज होगी टू फिट देयर. ओके, सो इफ आई सेट टेम्परेचर टू 0, आई एम डेफिनेटली टेलिंग एलएलएम के डू नॉट एक्सपेरिमेंट. जिसकी प्रोबेबिलिटी सबसे ज्यादा है ना, उसको यहाँ पे फिट कर दो. दैट्स टेम्परेचर 0. बट इफ आई एम सेइंग टेम्परेचर मोर टुवर्ड्स क्रिएटिविटी, सो आई एम सेइंग कि do not always go with the best option, because then it is more rule based, वो repetitive है, and that is more expected. थोड़ा सा मुझे surprise करो, give me more creativity. Okay, so 2 will let it choose some of the outputs which were less probable, but still it's creativity which is coming into picture. That's the idea of temperature. p tokens भी वही करता है, it does exactly same thing. Rather than controlling the deterministic and creative approach, वो टॉप 10 प्रोबेबिलिटी वर्ड्स ही लेना 100 में से, टॉप 5 ही लेना. तो दैट्स टॉप पी 5 10 ऐसे लेना. ठीक है, एंड देयर आर अदर वेज लाइक स्टॉप पेनल्टी, फ्रीक्वेंसी पेनल्टी, व्हिच कैन बी एडेड ओवर हियर. स्टॉप सीक्वेंस के अगर ये वर्ड आ जाए तो यहाँ पे स्टॉप कर दो. आउटपुट लेंथ कितना होना चाहिए, टॉप पी क्या होना चाहिए. दीज आर फ्यू ऑफ द वेज थ्रू व्हिच अगेन यू कैन कंट्रोल एलएलएम. Okay, then there is post generation guardrails. So guardrails again, ये concept थोड़ा AI agentic AI का concept है, but again this can be used to generate. अगर suppose I'll train my LLM that you will never explain horror stories because the audience, they do not like it. So I can create a guardrail that if at all words like horror or maybe like something like paranormal are coming into picture, block this output. So even those can be used. Third is structured response. So whenever I want APIs, when I'm working, I want JSON response. So I can force the model to always respond to me in a given structure only. Finally, if these things are not working for you, but these are quick fixes, ये आधे दिन का, एक दिन का, मतलब prompt engineering आप एक दिन में अच्छे से prompt master कर सकते हो. Decoding parameters you can play around with a day or two. Guardrails, structure response schema in a day or two बना सकते हो. But if these are not working for you, you're, for example, these are just tweaking over an car. जैसे मान लो मैंने एक कार खरीद ली 1 लीटर की टर्बो पेट्रोल इंजन. अब इस पर मैं थोड़ी ट्वीकिंग कर रहा हूँ. मतलब आई एम ट्राइंग टू maybe map the engine differently. I'm trying to change wheels. I'm trying to change weight. थोड़ा हुड चेंज कर दी, एरोडायनामिक चेंज कर दिए, just to control the performance of the car I want. But अगर वो इंजन अपने आप में ही उतना well designed नहीं है, तो ये जो tinkering में कर रहे हैं, this is not working out. This is the reason why fine tuning is here. Now, the reason of fine tuning is that all the other options to control LLM, they do not change weights. वो weights को change नहीं करते, वो architecture को change नहीं करते. Input, output, attention layers, position encoding layers, input encoding layers, decoder layers, ठीक है, softmax layers, ये मतलब जहीं मतलब जो पूरा architecture में जितना भी weights designed है, they don't touch it. Okay, model वो इंजन वैसा ही है. बट फाइन ट्यूनिंग इज व्हेन जब आप इंजन खोल के इंजन पे काम कर लो. अब अगर एक पिस्टन और बोर है, अगर आप बोर साइज बड़ा कर दो तो आपने इंजन को उतनी सीसी बड़ा कर दिया. सो मे बी मेरी 650 सीसी की बाइक है, मैंने उसको इंजन में बोर मार के थोड़ा उसको 800 सीसी की बाइक बना दिया. सो ऑब्वियसली वो पेट्रोल ज्यादा खाएगी और पावर भी ज्यादा देगी. तो दैट इज फाइन ट्यूनिंग. आई एम कंप्लीटली रीडिजाइनिंग द वेट्स ऑफ द मॉडल. ओके, सो that's about it. Okay, so I think I just covered कि prompt engineering और fine tuning में क्या फर्क है, and this is the idea people that fine tuning क्या है. Okay, now we have set premise, we have covered the syllabus for today, but before we start day 2, there is a very important thing for us to keep in mind, that fine tuning is no joke. I just told you that just to store these models, run these models, you need 10 to 12 lakh of machine to just store it, even in a mediocre level pay. If you want to store it in a proper full functional 70 billion model at full precision, you might need a huge amount of investment. So for example, there's a website such as AMXPL. If you go here, there's a VRAM calculator. So for example, if we have to host, say, llama model, I'll just go for llama 70 billion model, okay? And I'll go for fine tuning. I'll go for full method, okay? And just to fine tune this model, I need 1000 GB of RAM, okay? So just imagine this kind of machines will cost you in crores, okay? This is crores and crores of rupees which will cost you just to run this model, because normal machines can't do it. So, which is where concepts like PEFT or parameter efficient fine tuning comes into picture, that makes it possible for people like us to train the model. And we will talk about this parameter efficient techniques tomorrow in depth. What are these techniques supposed to be? And day 3, we will apply them. Okay. Are there any pending questions? It is interesting. Time taken equals to number of tokens. Yes. The latency also depends upon the number of tokens involved here. So I think I tried to keep it high level, but again, this is a very technical topic to discuss. So we had to dwell into the depths. Okay. Again and again, repeat some concepts, and now we are good to go. Any final question for the day, or we can call it the night? Let us see. All right, let me just refresh my chats in case they are stuck. All right, cool. I think we are good to go. With this, we will stop today's session. Bye-bye, Tata, sayonara. Thank you so much for joining in. If it was an interesting session, I'll see you all tomorrow. Good night.